the South Pole with a side tour to the Arctic to get an understanding of the relationship between the polar regions and climate. Years ago, when I was a graduate student, I had the opportunity to live and work at what has been called the last place on Earth, South Pole Station, Antarctica. This is the sign that greeted me when I arrived, and this was in October. Temperature was about 60 below zero Fahrenheit without the wind. We lived underneath the geodesic dome in some buildings that were sheltered by the dome. The conditions at the South Pole seem to defy reality, challenging our understanding of weather and climate. We are at an axis of the Earth's rotation, which means that in summer, the sun circles around, reaching higher until it gets to the solstice and then circling its way down. We have, at the South Pole, we have 5.5 months of total daylight, 2 weeks of sunset, 5.5 months of darkness, and 2 weeks of sunrise. This is a condition where if the air is so cold that it pours off the continent in the form of katabatic winds, and the air is replaced by winds aloft. And it is so cold that the moisture in the sky, moisture falls out of the clear blue sky in the form of clear sky precipitation, known as ice crystal precipitation. And this is a 10-month, or actually a 10-minute precipitation event. Not a whole lot. The air is very dry. The ice crystals will form some unusual effects. You'll see the whole horizon lit up by ice crystals. And there's nothing but sky and ice as far as you can see. Sometimes it's easy to tell the difference between sky and ice, and sometimes not. Try flying an aircraft under these conditions. The ice cap is 2 miles thick. These are the buildings that are underneath the dome that prevent exposure from all the wind and all the cold. 20 below zero Fahrenheit is a typical warm summer day. The coastal regions are warmer, but these are the conditions that we have in this area. And we get our supplies from incoming flights. That is our lifeline to the rest of the world. And part of my job while I was working there as a graduate student was to take aircraft, or take weather observations for incoming flights, and also to launch weather balloons with instrument packages so we can get data and understand what the conditions are for the aircraft coming in. And this is one of my fellow researchers, and he's standing there compiling data with a state-of-the-art computer, state-of-the-art 50 years ago. Your cell phone probably has more computing capability than this machine does. And the dome is meant to deflect the snow, but it's not doing a particularly good job. It's piling up, and we take the opportunity to go dome sledding, but we take our work seriously. We have our lighter moments. And as I said, there's nothing but sky and ice as far as you can see. We're on an ice cap 2 miles thick. We are hundreds of miles from any other life forms. Why are we here? We're here to gather information about our planet. And I learned a lot when I was there, and I use that information today. Now, as you can see, we have a new South Pole station. The old South Pole station is sinking slowly into the ice because of weight, because of the accumulation of blowing snow. That is actually, the dome station is actually the second station. The first one suffered the same fate. It eventually sunk into the ice after about 20 years of use. And the new one is designed to stay above the ice to avoid accumulation. You can, they can raise it. This is their solution to the problem of accumulation. The ice does move. It moves 30 feet a year. So that means if you plant your instruments in one location and you come back the next year, it would have moved 30 feet. And to do a comparison here, the Antarctic continent is it's an ice continent surrounded by ocean. The Arctic, on the other hand, is essentially an ocean surrounded by continents. And the Arctic also has the Greenland ice cap, which is similar to the Arctic, to the Antarctic ice cap. Both ice caps are 2 miles thick. And the coastal regions do have precipitation events in Antarctica. The interior is mostly clear sky precipitation, not a whole lot of accumulation. When we compare the continents, or we compare the polar regions, we have to consider that there is sea ice. This is a map of where the sea ice is located, and that is a current map as of September 30th of this year. And you note that that it's very close to what the median ice range is. Now the Arctic is a different story. You'll notice that there are ice-free regions in the Arctic, and that varies considerably during the seasons. You'll note that there are a lot of ice-free regions. This is a September picture where the ice is probably at its minimum extent. Later on it will grow to a larger region. The Greenland ice cap is subject to melting. The sea ice is variable in both polar regions. The ice cap in Greenland is subject to melting. The Antarctic ice cap is not. What does happen in the Antarctic is warm water undermines ice shelves, and you get crevices and breaking of the ice cap in which the ice falls into the ocean. This is the Thwaites Glacier. It has been publicized quite a bit. People call it the Doomsday Glacier. Now I mentioned that at the South Pole, the ice flow rate was 30 feet per year. The Thwaites Glacier is 3,000 feet per year, so like half a mile per year is how fast this is moving. And we were concerned about the impact of this glacier, but how do you communicate this? I've heard people talk about ice collapse. Well, if it's going to take 200 years, is it a collapse? There's different ways that you can communicate, and there needs to be a way that we can discuss this. And I receive email from all kinds of sources on Arctic and Antarctic information, and just trying to wade through all the information. You have to look at it and then decide, does it make sense? Now, just to reacquaint ourselves with the energy balance, the visible light from the sun is absorbed by the surface, and the surface of the Earth re-radiates infrared. And it's the greenhouse gases that are not on this chart, which might be appropriate because they're invisible anyway. The greenhouse gases absorb and re-radiate heat energy. And the greenhouse gases play a role in regulating the Earth's temperature, but if we have an excessive amount, we get more radiation back to the surface of the Earth. The polar regions have the highest reflectivity of any other place on Earth. Both the Arctic and, or rather the Greenland ice cap and the Antarctic ice cap, you can see there's a lot of reflectivity off of that surface. Now, what we find is the reflectivity, or the albedo, has an impact on what's going on. The ice surface reflects most of the energy back, but the water surface absorbs most of the energy. So that means that the less ice there is, the more energy is absorbed by the water, and the warming water melts more ice, and you get a feedback situation. Another effect of warming of the polar regions is that the westerly winds are driven by the temperature contrast between the polar regions and the equator. So if you weaken that difference, or if it's less, then the circulation becomes, the winds become lower, and the atmosphere becomes more wavy, in which case you'll get waves that may or may not move particularly fast. You'll get prolonged periods of cold or warm or precipitation. A one-day precipitation event might become a 2 or 3 day precipitation event. And it also ties in with the polar vortex, although it's a little bit more complicated than what is indicated here. And these are the temperature trends that we need to look at. The global average trend over 30 years has been a 1.4 degrees Fahrenheit increase. And Grand Rapids is 2.1, and we've seen that with other presentations. It's very similar numbers. The South Pole, 3.2, that seems odd, but because the South Pole circulation, when the wind is pouring off the continent and drawing air in from other locations, it's like a giant global vacuum cleaner. It ties, the South Pole temperature ties in with other circulation systems in the Earth, or around the Earth. So that's why that is warm. But you will note that the last one, Utqiagvik, Alaska, also known as Barrow, 5 degrees temperature rise in 30 years. You can imagine that, take all the temperatures that you experience in the course of a year, add 5 degrees, and that's what you get. And this is why the Arctic regions are very prone to melting and warming because of the feedback mechanism that we talked about. Lessons learned. Well, we've learned that the Arctic and the Antarctic regions are very vulnerable to climate change. We have an impact on those regions, and the regions have an impact on us. And the last slide I'd like to show is, yes, there really is a South Pole. This is the ceremonial South Pole, surrounded by the flags of the treaty nations. And Antarctica technically is under international law. And living under international law, you kind of feel like you're a world citizen. Well, you don't have to go all the way to Antarctica to be a world citizen. We already are world citizens. We do what we can to, we find our role and do our combined efforts to protect the planet and deal with the issue of climate change. That concludes my talk. Thank you for giving me the opportunity to speak, and we'll go on to the panel.